In this video, I am going to discuss about the pseudocode to perform an insertion in a circular queue. Let's start writing the pseudocode. The very first step is we have to check whether there is a space left to insert a new element or not, because since we want to perform an insertion, only if there is a space in a queue we will be able to perform an insertion. To check for, which means you have to check for a overflow condition. When it comes to the queue, when it comes to the circular queue, if you want to check for the overflow condition, the condition here is already would have discussed in the last video. The condition is if front is pointing 0 and rear is equals to max minus 1. This pseudocode is for implementing a circular queue using array data structure. So, normally in a linear queue, if you want to check for overflow condition, you have to check if rear is equals to max minus 1, right? And we discussed that there are some drawback in linear queue. To overcome the drawbacks only, we are preferring this circular queue structure. So, in a circular queue structure, when we would say it is the queue is overflow, means when front is pointing 0 and rear is equals to max minus 1. If you check queue number 1 here, yes, front is pointing 0 and rear is pointing max minus 1, because the maximum value the queue can hold is up to 6. So, if rear is pointing max minus 1, which is 5, which means the last position, if the rear is pointing the last position and front is exactly pointing the first position, means the queue is completely full. So, print overflow and we can go to the next step. The very first thing is we have to check if the queue is completely full. If the queue is completely full, it would look like this. The full queue would look like this. Check queue number 1. Next, if the queue is not full, we will take the second scenario, the queue number 2. Now, the queue is you came to know that the queue is not completely full. In such case, you have to check for another condition, which is the element, the data element which you want to insert is going to be the very first element you have to check, because if it is very first element, the condition is different. If there are elements already, so your element is also going to act one of those elements in a queue, means the condition is going to be again different. So, you check the next condition is whether the element which you are going to insert is going to be the very first element, you have to check. So, the condition here is means what? The queue is completely empty, your element is going to be the very first element in the queue. For example, value 5 I want to insert. I want to insert the value 5. Check for the condition to check whether the queue is empty. If front equals to minus 1 and rear equals to minus 1, when front and rear would be minus 1, when the front and rear would be null, when there is no element in the queue, front and rear would be pointing minus 1. If you check example 2, queue number 2, yes, it is completely empty. Since the queue is completely empty, there are no elements in the queue. Since it is completely empty, front is pointing minus 1 and rear also is pointing minus 1. In such case, we are supposed to set, which means we are supposed to make the rear pointer as well as the front pointer to point to 0. Yes, point to 0, where is 0th index here. So, make these two pointer to point 0th index, and after that in the place of rear, in the place of, after setting it to front equals to rear equals to 0, in the place of rear, since only at the rear position we can perform insertion, in the place of rear we can insert the value which you want to insert. Q of rear equals to value. Q of rear is 0th position, here you can insert new value. This is another condition. First condition is check for overflow. Second condition is check whether the element which you want to insert is going to act as a very first element in the queue. The third condition is check example number 3 here, Q number 3. The condition is rear is pointing max minus 1 and front is not pointing 0, because when the rear is pointing max minus 1, the next position to insert is in the place of 0 only it can be inserted, right? So, this condition is something different. So, the condition is if front and rear is not equal to minus 1, which means there are already elements there. Check for the condition if rear is pointing max minus 1 and front is not equals to 0, which means at the front places there are spaces left to insert a new element, right? My rear is pointing max minus 1. So for rear, the next position is going to be 0 since it is a circular structure. So if rear is pointing max minus 1 and front is not equal to 0, you are supposed to set in the next iteration rear equals to 0. After setting up rear equals to 0, now the rear would come here. Now rear would be pointing the index position 0, and this statement would get executed. In the place of Q of rear, you can place the value which you want to insert, that is 5. This is third case. The fourth case is else. If this condition also fails, this condition also fails, simple. The normal condition, it is going to be normal linear Q condition, which is front is pointing 0, rear is not pointing max minus 1. Simply you can increment, you can set rear equals to rear plus 1, and in the place of rear you can insert the value. So here if you check, yes, it fails, both of the condition fails. It is not, sorry, all these three condition fails. There is no overflow condition, there is no front equal to minus 1, rear equal to minus 1, check for example 4, and there is no rear equal to max minus 1, front not equals to 0. If so, this is the condition. Simply you can increment rear equal to rear plus 1, and in the place of rear you can insert the value which you want to insert. Yes, we have completed all the steps, so you can exit the pseudocode. Let me explain again. There are totally 4 conditions you need to check. First condition is check whether it is overflow. To check for overflow, this is the condition. If front is pointing 0 and rear equal to max minus 1, check Q number 1. Yes, front is equals to 0, rear equal to max minus 1, print overflow. Else, if it is not full, you can start inserting the value, right? And the first condition is check whether the value which you want to insert is going to be the very first element. When the queue is completely empty, your front and rear would be pointing minus 1. So you can set the front pointer and rear pointer equals to 0, and then in the place of rear you can insert a new value. It would come out of this if statement completely, and in the place of Q rear it would be inserting the new value. Suppose if this condition fails, it would check for the next condition. Check Q number 3. Rear is pointing max minus 1, rear was pointing max minus 1 here. If rear was pointing max minus 1, and if your front is not equals to 0, which means at the front position there are spaces left. So after reaching the rear, after reaching the max minus 1 position, the rear would be incremented to the 0, and in 0th place again new value can be inserted. Otherwise, the normal scenario only, simply you can increment rear equal to rear plus 1. So rear would get incremented here, and now in the place of rear you can insert a new value 5. This is how the circular structure works when it comes to insertion operation, and in the next video I will discuss the deletion operation.